Hello everyone. So welcome back to my channel and let's start with another question of our Leetcode 75 playlist. Till now we have completed 23 questions around sliding window, array and strings, hash map, and let's start with today's. This is related to binary search. So let's start with today's question. So we are given guess number higher or lower. So this is an easy question from Leetcode. So let's just read the problem statement to understand it. We are playing the guess game. The game is as follows. I pick a number from 1 to n and you have to guess which number I picked. Every time your guess is wrong, I will tell you whether the number I picked is higher or lower than your guess. Okay, and it will automatically call a predefined API internally which will return three possible results. Okay, and in case it is -1, that means that our guess is higher than the number that I picked. Okay, 1 when your guess is lower than the number that I picked. 0 your guess is equal to the number that I picked. Okay, and whenever like it is 0, we will return that number, right? So we are given this input in 10, pick a 6, so it will automatically return 6. Okay, so it should be in the range, I guess, because that is mentioned. In case like this 1 2 1 is already in this range, so it will return similarly, but in any case it comes out of the loop, this range 1 to n, it will return -1. Okay, yeah, higher than the number. Okay, so let's just start with the intuition part to better understand it. Okay, so we have n and we have our pick. So what we can do, basically we will we have this pick. When we like return 6, with the 6 value we call their guess API, right? There's a API that they have mentioned. We will call with 6, it will return 0, and if we call with 5, guess of 5. So what it will do, since 5 is smaller than the pick, so it will return 1. Okay, and if we call with guess of 7, okay, it says 7, so it will return -1, as it is mentioned that whenever this number is greater than the guess, this is the pick that number and this is our guess. Okay, so if it is greater, it will return -1. If it is smaller, then it will return 1. If it is equal to this, it will return 0, right? So these three are the conditions. So what we can do, so this is if we like read from the problem statement directly without knowing that whether it is related to like search, binary search or linear search. Okay, you should not directly move to like any optimized solution, because it should be like starting from the basics, so you will also be like very confident when you are giving the final answer. So that should be like first you start the brute force. So what will the brute force approach? Okay, so you have a range 1 to n. Okay, n is already given to you, and you just have to in this range you will call for each number their API, which will return you like the result, their API, that is guess. So the brute force will be, what will you do? You will call for all the numbers in between this range 1 to n. As it is mentioned, the number is in the range. So like you can call for 1. Okay, let's just say take an example that n was 10 and pick was 6. Okay, so what will you do? You will call for 1 to 10 for all numbers. For 1 you will call guess of 1. Okay, so guess of 1 will return you 1. That means your current number is smaller, you will move forward. Guess of 2, right? So it will also return you. Similarly, you will call till 6. Okay, so when guess of 6 will comes, it will return you 0, and whenever you get 0, Okay, so we'll just write it. Okay, when you will get 0, from here you will get 1 1 1. Whenever you get 0, that means that you got your answer. You will like return from that loop or exit from the loop, and you will return that answer, that is 6. Okay, return 6, the number you are currently on, 6, right? So this is a simple brute force approach that you can like first answer whenever this question comes in your interview. Okay, now the time complexity that you will analyze in this, since you are going for all numbers from 1 to n, let's just say if your pick is not 6, it was like 10, right? So you will go from 1 till 10 for all values, and every time you will got 1, and you will not face this condition anytime -1. ठीक yeah. So what is that time complexity? Time complexity will be big of n, right? And space will be big of 1 only, since you will be like using in only like variables. So this is if the, let's just say n is till 10 raised to power 9. Okay, so this will be till 10 raised to power 9, which is a very high time complexity, and it is not good to provide the solution in this time complexity whenever the constraints are very large, right? If it is like 100,000, in that thing you can give on, but whenever the constraints are very large, you should try to optimize this big of n complexity. So now comes the approach of optimize, that is our binary search. So okay, so let's just understand it. I will also be making a complete video for this binary search to better understand it from scratch, like how it is done properly. Now I'll just try to give the glimpse of this. So let's just say you have this array, and it is 0 1 2 3 4 5 6 7 8 9 10, let's just say 11, and this is 12. Okay, you have n equals to 12, so you have this range. N equals to 13 can see. Okay, n equals to 12 will work, and pick is equals to 8. So now what we'll do, we will start from this. We will take first pointer, that because our values in the range 1 to 12, right? So this is the index that I did, so we'll just remove it. Okay, so we have this array 1 till 12. Okay, now you have to search for 8. So what will you do? You will divide this array into two parts, right? So 6 values will be on the left, 6 values will be on the right. Now what you will do? You will find your middle. So middle is, this is, you will take your pointer from here, left, and right will be here. Okay, so it will be 1 plus 12 by 2. This is how you find the middle value. Let's just say you have 12 and 13. What is in their middle? 12.5. So how you will do? 12 plus 13 by 2. That's how you will get 25 by 2. This is 12.5. So this is the generic approach to find the middle. Okay. So what you will get for middle? 6.5. So you will take the integer value 6. You will find this value, right? Okay. So you will get this value. I will take another pen. So this is the value that you will get, 6, right? This is your middle. Now you will check if your middle value is less than, greater than, or equal to. Since you will call guess API with this value, guess of 6, because that's how you got that 0, 1 and -1 values. Okay. So guess of 6, what will you return? 1, because 6 is smaller than 8. That means that all the values on the left will be smaller, smaller. Okay, since all the values on the left are less than this middle, so what you will do, you will go on the right. Now you will, this left pointer will move to here. Okay, now right was here, left was here. Again you do the middle thing. So left is at 7, right is at 12. 7 plus 12. Again you find mid. Now mid will be, that is 19 by 2, that is 9.5. So if you take the value, integer value, it will be 9, right? Now you will come to this position, 9. Now you will call with guess of 9. Now you will get 9 is greater than 8. That means you will get -1. Okay, -1 will give you 9 is greater than 8. Then you will shift your right to middle -1. So this will be a middle. So before middle, because this is not equal to your pick and this is greater. So you will always find it here on the left. So now your left is at 7, right is at 8. What is your middle? 8 plus 7 by 2. So it will be 15 by 2. So if you take the value, it is 7. You will come here only. Now you will check if my guess, you will call with guess of 7. Guess of 7 will give you 1 because 7 is smaller than 8. Now you will shift your left to next position. Now left and right are at 8 only. So left at 8, right at 8. Okay. So middle will be 16 by 2, that is 8 only, this position. And when you call with guess of 8, you will get 0 because 8 is equals to 8 and you will return your answer. So I think this is pretty messy. I will take another example, just a small example, okay, with the small constraints. So you have n equals to 8 and pick equals to 3, right? So you will create an array 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll rub this one, right? So for this binary search, you will start, you're taking your left pointer here and right pointer at the end. Now you will find your middle. Middle will be 1 plus 8, 9 by 2, that is 4.5. So integer value will be 4. So you will, middle will be at 4. Now you will call with guess of, first is guess of 4, right? Guess of 4, since pick was 3, it will return you -1. So that states that value is in the left side. So you will reject all the right side including this value. So you will shift your right. Now this right will come here, right? This 3. So now left was, let's just say left was 1 and right was 8 in the first step. Now in the second step, left is at 1, right is at 3. Now what will you do? You will find your middle. Now middle will be 1 plus 3 by 2. 1 plus 3 by 2, that is 4 by 2. 4 by 2 is 2. Now mid is 2. Okay, now you will call with guess of 2. This will return you 1 since 2 is smaller than 3. Okay, now what will you do? You will shift your left to next of middle. So your middle was here. So next of middle is 3. Now your left is 3, right is 3. Again you will find your middle. Middle will be 3 plus 3 by 2. That is 3 only. Okay. So you will call with guess of 3. That will return you 0. That means you have found your answer. So it will be 3 you will return. Okay. Since if you can count these 3 operations you will do and the size was 8. Okay. So what is the relation? So 2 is to power 3 is 8. So that means you are almost log n time you are taking, right? Because if you take log of 8, that is log raised 2 raised to power 3. So 3 log 2. So that is around 3. Okay. Sorry. So the time complexity, if we analyze, how we are analyzing. So if we see, every time we are dividing the range in half and discarding the second half. So in every operation we are dividing into 2, again dividing into 2, again dividing into 2. So that gives you time complexity of log n, right? Which is the time complexity of binary search. And the space complexity will be big of 1 only. Okay. So this is big of log n and this is big of 1. So I think we are pretty much good on the approach. So let's just start with a coding solution. So we will have our left for 1 and right will be Rn since it is in the range. Okay. And now we'll start our binary search left till it is reaches right. Okay. Now we will find our mid, that is left plus right by 2. Okay. So now what we'll do, we will find our value. We'll call the guess API with this mid. Now this check will have our answer. So we'll check. If check is 0, that means our mid value is equals to our guess, uh, our pick. So what we'll do, we will return our mid. If it is not, then it will give you either -1 or 1. So we'll check for 1. If it is 1, that means that our guess is lower than the number picked. So we'll have to search for the right space. So search in the right space, right? So now we'll do shift our left to mid plus 1. If it is 0, 1, else it will come -1. 3 values it can give. Okay, so that means we have to shift our right to mid -1. Okay, that means search in the left space, and this means that we have found our answer. Okay, if it comes out of the loop and it cannot find this in the range of 1 to n, that means that the number that is picked by this a person is not in our range, so we'll return -1. Okay, so let's just try to run it on example test cases. Think, yeah, so all example test cases, yeah, it is working fine for all the example test cases. Let's just try to run it for all. Okay, so submit it. Okay, so this is giving a integer overflow. So yeah, this is main thing that comes in general binary search. So whenever you add two numbers, if let's just say, since we check the constraint that our n is in this integer range, so it can give a overflow exception. Okay, so for that, if you want to get your middle in the range, what you will do, you will need to calculate middle with this left plus right minus left by 2. Okay, so this should be the formula that you should use for calculating the middle, right? So I will give you a short glimpse why it works and why doesn't work. Okay, so let's just try to submit it again. Yeah, it is working fine with all the test cases. And yeah, thanks everyone. So let's just move to the iPad again. Okay, so why that thing was working. So let's just give a short glimpse that you have mid as left plus right by 2. And if we write it, mid equals to left plus right minus left by 2, right? So as we have seen that it was giving an error while we are doing the first thing, this thing, and it was run when we are doing this thing. So why did it happen? If we check, so if we take integer value, max value, max int value, that is like 2 into 10 is to power like 9, I guess. So max value that I've seen is 2147, 483, and 647. If that is the value that is given on Google. So this is a maximum value of an integer. Okay, so let's just say this is max value, this is the max value, and as we are given the constraint, it is 2 into 10 is to power. If we check, 2 into 10 is to power 9, right? So similar to that thing. So integer max is 2 into 10 is to power 9. So let's just say 2 into 10 is to power 9 is this, 2 into 10 is to power 9 is this, right? So if we just add it, what it will be? It will be 4 into 10 is to power 9, and this is not in integer range. If we carefully observe, uh, if we should half it, then it is in the range, but this is not in the range. Okay, and when we are doing this thing, it will first add, then it will divide. So this addition is giving that overflow exception, right? But if we do from this approach, the second approach, okay, so how it will do, this is left, so it is 2 into 10 raised to power 9. This is right, this is left, so it is 2 into 10 raised to power 9. This is 2 into 10 raised to power 9, right? So what it will do, left is similar, right minus left, this will be 0, by 2 nothing. So we will get this, since this is in the range of integer, since this is in range, so it will not break. Okay, and you can get this formula from this formula also. If you carefully observe how you can get, let's just write it, mid equals to left plus right minus left divided by 2. Okay, so what it will do, let's just expand it. So it is left plus right divided by 2, left divided by 2. Okay, so we will do operation on this. So it is left plus left by 2 and plus, okay, sorry, left minus left by 2 and right by 2. Okay, so if you do this, it will be automatically left by 2, and this is right by 2, and if you take 1 by 2 common, it will be left plus right. So you got this formula from this one. So that's why, so only that integer size thing was giving the overflow exception. Due to that we have this used. So this is a logic behind that, and I will be creating a complete video over the binary search. So yeah, thanks everyone. In case you have any comments or any other approach for this question, please do ask in the comment section or add it in the comment section. I will try to review it and reply to that. Yeah,